This will be problem number 3 from the 2022 AP Calc A, B, and BC exams. And this one is pretty typical of what number 3 involves. We've got a graph of a derivative, and they tell us that f is a differentiable function. F of 4 is equal to 3. Then they want us to consider the interval 0 to 7. That's what we're provided with the graph of f prime for. It's consisting of a semicircle, so it's pretty obvious where that sits, and then the two line segments that we see here. We want to find two things in part A. We want to find f of 0 and we want to find f of 5. I actually think f of 5 is easier to determine, so why don't we talk about that first. So this bottom calculation here, I know that my function value at the x of 4 is 3. I would like to find my function value at the x of 5. So you've done stuff like this in application a lot. You haven't done it without any context nearly as frequently. If you think of this as the application that you've probably done most frequently with regard to functions and their derivatives, that would be the function is a position function and the first derivative is a velocity. What we have access to here is essentially a velocity graph. And what this condition right here is the position of the particle at time 4. So what we're asked to do here for the x of 5 is we're essentially asked to find the position of the particle at time 5. So we're going to take the position at the time that we know it, which is at 4, and we're going to add on how much the function value changes by, or how much the position changes by, from time 4, the time that we knew it, to time 5, the time that we want it, by integrating the rate of change of position, which is velocity. Well, without the context, we take the function value that we know, and we add on how much the function value changes by from the x of 4 to the x of 5 by integrating the rate of change of the function. Now, to determine this value, you do have to use some area arguments. You see I drew this little triangle right here. On the x-axis from 4 to 5, I have a triangle that sits above it. So I'm going to add on 1/2 base times height. This answer right here would receive full credit. You don't have to simplify in these FRQs on the calc test. If you did try to simplify that, it does turn into 7/2. We will actually need that a little bit later on, so we'll benefit by having it into a nicer value here. F of 0 is a little bit trickier. I'm going to go with the same process. I'm going to take the function value that I know, and I'm going to add on how much the function value changes by from the time that I know it to the time that I want it by integrating the rate of change of the function. Now, the issue here is in order to use signed area arguments, your limits of integration do have to be in the proper numerical order. Smaller value at the bottom, bigger value at the top. So I'm always able to flip my limits of integration as long as I negate the integral. And so if I think about subtracting off the integral's value from 0 to 4 from 3, what I'm going to have to do is I'm going to have to subtract off the area, the signed area, on this stretch of the x-axis. So a little tricky here because we're subtracting, but then that space also sits below the x-axis. So we're going to have to basically negate the area of that semicircle and subtract it off of the 3, which doesn't end up adding it back on. But if you weren't careful back with how you built this original calculation with making sure the limits were in the proper numerical order, if you didn't have enough negatives floating around, you wouldn't have gotten to this result. Again, you don't have to simplify it to 3 plus 2 pi. You very well could have left your answer looking like this. Part B wants us to find the x-coordinates of the points of inflection of f on the interval 0 to 7, and then we are asked to justify our answer as we always are. So you hopefully realize points of inflection are places where the graph changes concavity. Concavity is determined by the second derivative. So normally I would advise my students to build a sign chart for determining concavity and points of inflection. So I built a sign chart for f double prime. I had to look at the right stuff here. So this little bullet point right here, f double prime is going to correspond to the slope of f prime because f double prime is the derivative of this graph that we have access to. So anywhere where we have negatively sloped tangents on f prime, like we do here, we're going to have a negative value for the derivative, and that happens again right here. Should use better terminology here. We're going to have a negative value for the second derivative, right? The derivative of this graph is really the second derivative. So we have a negative second derivative due to the negative slope on f prime here. We also have negative there, and then we're positive on those other stretches from 2 to 4 and then 4 to 6. I considered 4 as a place where I was going to have a potential change because there is a cusp on the graph at 4. My tangent slope on f prime is technically not defined at 4. I very well could have a change in slope as I pass through a location where my slope isn't defined. The two places where we do change concavity, and direction of the change doesn't matter. It can be concave down to concave up to concave down. As long as you have a sign change for the second derivative, you have an inflection point at any location where that happens, and that happens to the x value of 2 and the x value of 6. In part C, they define a new function. This new function is g of x. It's equal to f of x minus x. They ask us where g is decreasing on the interval 0 to 7. We want to show our calculations and analysis. So I realize right here, g decreasing. Well, if g is decreasing, that means g prime is less than 0. So I need to know what g prime is. So I take my derivative of g real fast. Not too bad. I don't need a product or quotient or a chain rule or anything too difficult. Just the derivative of f minus the derivative of x. So that's where I get this from. I want to know what my critical numbers are. Where might my first derivative for g change signs? So I set this equal to 0. And to solve this, I can actually add the 1 to this other side. And in doing so, I need to know when f prime is equal to 1. Well, this is a graph of f prime, and f prime is equal to 1 right here at 5, and then again right here at 7. Now 7 is an endpoint, so I don't really need to do anything on the bigger side of 7, but on the two sides of 5, I'm definitely going to have to consider what's going on. So what's going on with this over here at a value from 0 through 5? Well, if I'm from 0 through 5 with my x value, the value of this derivative, the value of this graph, is beneath 1. So if I take a value beneath 1 and I subtract 1, I'm definitely looking at a negative value. But then if I'm above the y value of 1 with my graph, like I see I am on the interval from 5 the rest of the way to 7, my derivative is going to be positive. G is decreasing on the interval from 0 to 5 since g prime is less than or equal to 0 on that interval. I did include endpoints here. As long as there's going to be a point on the graph of g at the endpoints, you typically would include endpoints for intervals of increase and decrease. So that's really the only reason why I'm including them here. But we'll finish this up with a little discussion on Part D. Part D also deals with g. So in this case, we're asked to find the absolute minimum value on the interval 0 to 7 and then to justify the answer. So there are a couple different options that you have for this particular version of this question. I went with the option that I would say works more often than not. If you're asked to find an absolute minimum or an absolute maximum on a closed interval, what we typically like to do is we typically like to identify the candidates where the max and the min might be. So the endpoints of the interval, 0 and 7, and then any critical numbers within it. And we identified our critical numbers for g back in the previous part. The only critical number that we had between 0 and 7 was at 5. Now I would need to know what my value of g is at each of these candidates. So at 0, this was a calculation from back in part A, right? F of 0, we found that, so I'm literally just plugging into, now I don't have g anywhere on this screen, do I? I'm literally just plugging into the definition of g right here, right? So f of 0 minus 0 for g of 0. F of 5 minus 5 for g of 5. And then the same thing for 7. So f of 0 we got back in part A. Taking f of 0 and subtracting 0 just leaves us with 3 plus 2 pi. G of 5, well, that's going to be f of 5 minus 5. We also had this value, f of 5, 7 halves, back in part A. So 7 halves minus 5. Now I would, in a case like this, want to make sure I simplify that to a nice value that I'm clearly able to compare with the rest. So that answer from part A, 7 halves for f of 5, and then minus 5. If I find my common denominator, that's going to leave me with negative 3 halves. And then I didn't find f of 7 back in part A. So I do a little bit of work over here using the same sort of calculation as we talked about back in part A. So on the interval 4 to 6, I've got this triangle that sits above the x-axis. So I've got a 1/2 base times height calculation happening there, added on to the function value that we knew at 4. And then from 6 to 7, I see a trapezoid. So I've taken the average of the parallel sides multiplied by the distance between them. And if I simplify that, I get 13/2 for f of 7. So if I take f of 7 and I subtract 7, that takes me to -1/2. What's the minimum value of g? Well, the minimum value of g is the smallest value that we see. Having the work in place like we do right here, using the extreme value theorem like we have, is going to satisfy the justify your answer requirement. If you were going to use verbal arguments, which is possible here, based on the sign chart that we had back in part C, since g of x decreases from 0 to 5 and then increases from 5 to 7, the absolute minimum rather on g of x happens at the x value of 5, and then you would just have to make sure you don't say that the minimum is 5. Based on the wording here, we want to find the absolute minimum value. That's the y value, -3/2, that we've already determined based on our work right here. So there was another option here. If you have more critical numbers than we have, or if we were asked for the maximum, you wouldn't be able to use that same sort of logic. The maximum, you'd have to make sure you're showing what the y value is at 0, what the y value is at 7, doing a direct comparison between them. I know that this question didn't ask you to do that, but you don't always have a bulletproof argument by just using logic based off of a sign chart when you're going for an absolute max or an absolute min. In this case, we're okay. Decrease from 0 to 5, increase from 5 to 7. The absolute minimum has to happen at the x of 5. We go ahead, we make sure we recognize that the y value there is -3/2, and we're good to go that way too.